Hi there, welcome back to the channel and welcome to the second video in the restoration of this SABA Meersburg 100 full automatic stereo. This is where the mystery comes in. The stereo part of this radio raised quite a lot of interest in the comments in the last video, and it was indeed the puzzle that I'd been trying to figure out. I just could not figure out why they call this thing stereo when you see one tube, one output transformer, one power tube. This would have been magic. I was really hoping they'd found some amazing way of achieving that, but obviously they did not. So that was part of the confusion that this radio caused me when I first looked at it, before I started going into the schematic and everything else. And in this video, I'm going to do what I normally do, which is take things in stages: power supply, power amp, and that's where it stops on this one. And the results are actually very, very interesting. So if this sort of thing turns you on, stick around and enjoy the video. Before I carry on, I just want to thank the sponsors of the video, PCBWay.com. I've been using them for the PCB projects that I do on my channel. The prices are exceptional, turnaround time is great, and I really like the quote page over here, where you come in, select all the requirements for your PCBs, and it gives you an instant quote. I normally use the quick order, which allows you to just upload a Gerber file, and it automatically finds all the details it needs. You then select any particular characteristics, and again, the quote appears right here. Besides PCBs, they also provide an incredible number of other services. As you can see over here, CNC, 3D printing, sheet metal, injection molding, whatever you need, they've got for you. And just to help you with the order, there's a chat service over here, and you can get some live assistance to help you with the selections that you need to make. So whatever you need, whether it be the simplest PCBs or some really serious stuff, including assembly, CNC work, or 3D printing, the system is equally simple. You select a CAD file, get your quote, and order. So visit the website. I'm sure you'll find something for your needs. Looking at the chassis, the first thing you'll notice is that there's quite a difference between the left and right. The left is obviously not being cleaned, and the right seems to have been, well, not just cleaned, but actually painted. And the reason I did this is because some of the coloring came off when I started washing off the surface. I'll explain that in a minute, and you can see that I've actually managed to recoat the entire half of on the right hand side, and that's because that's where I've been working. As is my common routine, I started on the power supply, which means looking at the AC in, where it goes through the switch, what's before the transformer, what happens when it goes into the transformer, and where does it go when it comes out. So I decided to start cleaning up as I did the checking, and this involved painting the transformer, as well as painting the entire right hand side, cleaning all the wires, all those shields, those screens, and also changing the mains wire to a 3-wire and creating a ground, earth ground to the chassis. I'll show you all this in detail as we go along. Immediately after the mains transformer, the next thing is the filter capacitors, and here we see the filter capacitors on the top. Looks exactly the same, but it's cleaned, but it's actually been completely restuffed. I took the insides out, restuffed it with two 47 microfarad 450 volt capacitors, put this back. You can hardly tell it's been moved. The switch has also been properly cleaned, and there's also the two capacitors, the safety caps. We can just see there in black. Those were replaced with proper safety caps, and I put some black heat shrink on there just to make them blend in a bit more. As much as I like the original SABA plug, I decided I needed to change the cord to a 3-wire because I wanted to connect the chassis to mains earth. And that's exactly what I did here. I cut the original one about there, and then I got a 3-wire cord. I bent the green lead back. This is now covered in black heat shrink just to make it less obtrusive. That ground, or the mains earth, is connected to the chassis through that connection there. And then this is soldered on, heat shrinked again, and it's back to the original position with that holder. So this looks pretty much like it did before, except now we've got a black wire over here. I left the selenium rectifier in place because I'm not sure what kind of voltage drop this thing is creating. I'll only be able to figure it out at the end when everything is working, how much current draw there is, and then I will be replacing this for diodes and probably a dropping resistor or two. So that stays in place. This whole side has been repainted. This particular paint is very similar in color to the original. It doesn't have a gloss though, it's matte. And the reason I painted it is that when you start cleaning the chassis off with alcohol, I normally use isopropyl alcohol, the actual gray, that metallic gray comes off, and then you end up with the steel showing below, and I just didn't like that. It was patching everywhere, so I decided to do this. It's done very carefully. Screws are removed so that we don't end up with paint on them. The transformer was painted as well, the black sections of the transformer, as you can see here. This here is also cleaned up. Everything's cleaned up as I go along, so that I can then move on to the next section. And that on the schematic doesn't show much, because we actually just have wires coming in and a switch. And where is that switch? Well, here's the switch, and it was pretty gummed up, but it cleans off fantastically. It just came out very, very well. And I replaced those two safety capacitors. They were supposed to be safety caps. The caps they have on there were not safety caps, and they were already looking their age and looking in their condition. So I replaced them with two safety caps. These are 4.7 nanofarads, 400 and something volts AC. What the most we'll see is about 260, I think it is. So these have now been put in. And again, this whole section has been repainted with all these wires lifted before I put the paint on. Everything was done very carefully so I don't get paint on parts that are not supposed to be painted. So we've actually got part of the schematic almost done. The only bit that's outstanding on the primary side is actually the fuse. And it's a 400 milliamp fuse for 220 volts. If you use 110 or 125, you've got to use a 700 milliamp fuse. The fuse is fine. These contacts were cleaned because they were all carboned up. So it's making contact. This is set to the 220 volts, which is fine. This is actually the switched external supply. And this whole thing was cleaned up as well. So the entire primary circuit seems to be completed, right? All we need to do is check the function. And that's pretty easy to do. If we take a multimeter and just connect it across the two mains prongs of the plug, we see here that we've got an open circuit. And what we should be testing is the resistance of the transformer and the functionality of the switches and of the fuse. So if I push power on now, we've got 66 ohms, 64 ohms. That is the resistance of the primary, DC resistance of the primary of the transformer. So we can tell now that at least the primary circuit seems to be working, and we've changed the two components that needed changing on there, so we can actually just paint it. And of course, once we go through the power transformer, the first thing we meet is the selenium rectifier. Now, I'm only focusing on the secondary, or actually on two secondaries. The first is the one that's producing the B+, and the other one is the one that's producing the heater voltages, which is going to supply the tube heaters and the lamps and so on. I'm not going to focus on the motor sections here at the moment. We'll come back to that later. I'm interested in the function of the radio. So I'm leaving this selenium rectifier in here just until I know that the radio is stabilized, and I can then change this for 4 silicon diodes and work out how much voltage drop I need and so on. But it's been cleaned and it gets put back in place, so it looks good. So then, of course, I can't mark this as green. I'll just leave it as orange. And then we're on to the filter capacitors. This guy over here. And this guy's got two caps in there, 50 microfarads. Now this radio is slightly different in that the first capacitor does a smoothing. That is not really the first B+. It actually goes into a second capacitor. And the second capacitor then provides the first B+, which is going to go to the output transformer, through that to the anode of the output power tube. So those were the two capacitors that were completely restuffed here. They're brand new, they work very well, and this thing went back in perfectly. There was no problem finding the connections at the bottom and desoldering and putting the same ones back. It came out beautifully, and then we're on to the next step. And this is where things get a bit weird. You see, we've got the first filter capacitor over here. So that would be the first B+ from the main rectifier. Then we've got a switch over here, and this switch would cut off the entire B+ supply, right? You switch this off, no B+ goes to the radio. There's no B2+, no B3+, there's no B+ supply. Now what is this TST4? If we go down here and we look at the switching, here's TST4, so it's that switch over there. That is the stereo switch. Now this is the big puzzle of this radio. This radio is identified as a stereo radio. It is not. In fact, it's not even a stereo amplifier. The whole thing about the stereo which is amply discussed in the comments of the first video, is that it's not stereo at all. This was a gimmick and actually sort of cheating, a little bit of false marketing. When they said stereo, all this does is it turns this radio into a speaker for another application or amplification system completely external to this set. And we can look at the switching later and see what they're talking about. Whenever we see TST 1, 2, 3, and 4, that's what happens when you activate the stereo switch. Now this is really strange, because it serves absolutely no purpose at all. I mean, you might want some extra speakers, but the problem is this: when you switch on the stereo and you activate TST4, you are breaking this connection. You are cutting the B plus to the tubes and everything else. However, you're doing absolutely nothing about this secondary over here. So when you choose to use your nice SABA Meersburg Automatic 100 as a speaker for an amplifier that you've got somewhere else, you are burning heaters, lamps. You're providing the secondary full time. It heats up, it lights up, and it's doing bugger all. Bugger all, because your B plus is cut off. And that actually works. I've tested it. When I tested continuity, which I do, I activated the stereo switch, and I know that is the stereo switch. So I normally would put next to the switch what the function is, like that, so we don't get confused. But we can then continue and finish the painting, assuming or accepting that that switch is in place and it's supposed to be there. And here we are. We've got the second capacitor there that's inside the can, also replaced. And there is indeed 390 ohm resistor in here, pretty powerful one, and it's been checked and it checks out perfectly. So now we can paint these capacitors in, or this part is done. And this indeed does go, and I've checked it, up here through the output transformer primary into the anode of the EL84. It's easy enough to check. The tube is out, so you can just plug a multimeter into pin 7. Check continuity, you'll measure the resistance of this primary. So that's another one that can be painted in, and it is done. Now, what happens next? Where do the other B pluses come from? Well, they come through here. So we've got our B plus over here on the second capacitor. Then there's a 1.2K resistor, which is also perfectly fine. And we meet a 32 microfarad capacitor. This is where I had to use a different capacitor because 32, 33s, I don't have them. And I used a 47, and I actually managed to clip it down with the original clamp, sold it exactly where the other one was, and that's already in place. And that's what we've got so far. Actually, there's one more step you can take very quickly, and that is to check that it goes to pin 9 of the tube, and indeed it did. So that is our painting so far. Pretty easy. Once you get over the fact that they've used some false marketing over here, and by the way, that little capacitor over there, I also tested it. It's there to remove some noise, and it is perfectly fine. Starting to look good, right? Okay, one more thing. This capacitor is there again for filtering. Cuts out spikes, also those coming in here. This capacitor was changed, and this thing was in an atrocious condition. It was really, really bad. The end was popped out, the tar was leaking out. So that was replaced with a safety cap as well, 22 nanofarads. No problems at all. And that's our progress so far. Looking better. Now what do I need to do? I need to follow the schematic. I'm not going to follow this section here. This is the motor, steer motor. I said I was going to ignore that for now. I'm going to follow the B plus over here. I'm going to follow this section forward and make sure that B plus is getting to where it's supposed to. Like, for example, the anode of that tube, and so on and so forth. And that means we'll be able to test the entire B plus supply of the radio section and make sure that all resistors are within spec, that all capacitors are fine. There are a few more capacitors over here. I think there are a few small electrolytics that are also part of the supply. I'm not sure, I'll have to look for it. That's what I'm going to carry on with next. It's a lot quicker to show it on YouTube than it is to do it, I assure you, but all this has been checked. All these supply lines on the radio section have been checked. I normally connect the multimeter, say, to this point, which is the main B plus supply, really, for all the tubes down here. Connect the multimeter there and then measure resistance. And for example, in this particular line here to this point over there, what we expect to see is a 220k resistor, another 220k resistor, so we measure about 440 and we know this line is complete. I happened to have changed that capacitor right at the beginning when I changed the filter caps, because it was sort of stuck underneath and I thought it'd be convenient, so that had already been replaced. I think this is about the only one that really has an effect on supply. It is sort of filtering this drop across this resistor, so it sort of filters the supply as well. All the others are pretty simple. For example, on this line over here, what you expect to see, remember you're coming from here, along here, along here, along here, you get to here, and you've got a 3.3k resistor, then you've got one coil, two coils, and that goes to pin 7 of that tube. So you expect a resistance, a DC resistance, which will be slightly higher than 3.3k. And that is the case, so it means this whole line should be fine. And I did the whole thing here as well. For example, here, you can actually test this switch. So you're going from this point, and there's a switch already tested on there, but you're going from this point through that resistor, and it goes to pin 8. So you measure from there, actually measure from there, you can test the switches, and it goes through. You either measure 168k, or if you push U5, which is the FM, you'll measure 68k. So that tells you that that switch is fine as well. Same with another switch over here. Where is it? This one over here. It either supplies B plus to the ECH81 or to the FM front end. So again, all this can be checked. In this particular case, these supply lines can also be checked because these tube sockets are accessible. So pin 1 you can easily get to. So again, you can check continuity through there. You're supposed to have 10k there, and you're supposed to have 33k here. Yep. So again, all that has been checked and all that seems to be fine. I found nothing wrong with these resistors. As I mentioned, that one cap is one of the paper caps that came out. I've changed nothing else, and I'm ready for the exciting stage, which is what all this is about, and that is testing it, switching it on. All right, I think I've got everything ready to try the power up again. So what have I got here? I've got little brother testing or connected to the heater supply on that dial lamp. I've got big brother connected to B1 plus, that's straight out of the selenium rectifier. I've got 100 volts over there. I'm going slow. I don't want to risk it. This is a 220 volt system. So 100 volts. I've got maximum restriction. So one light bulb. Put that on here. And now we are going to hit on. And we'll look at that main light bulb over there. Not much, is there? It didn't even flicker. But then again, I've got very low voltage over there. We're on 135, 3 volts heater supply. I'm going to start turning this up. So let's try 150. Close enough. The radio is seeing 143 and it's drawing 60 milliamps. We've got our dial globes glowing there, and quite a few others on here as well, which we'll look at in a minute. 200 volts B plus. Let's go to 200 volts. I'm watching the dim bulb. 200 volts. It's drawing 80 milliamps. We're on 266 and 5.8 volts heaters. Everything's good so far. I've got medium wave or long wave selected, and we should see 291 volts, but that's not going to count because we don't have any tubes in there. Let me put it up to 220. It's about 220. Radio is seeing 204, 80 milliamps, 287, 6.3 volts. Well, that doesn't mean much. It doesn't mean much for various reasons. One, because I've got maximum restriction here. Two, because that's 220 and not 240, which is what we normally get, or 230 or so. So this is going to go up. But then again, when you put these tubes in and it starts drawing current, it's going to come down. So I don't want to unrestrict it too much. I might just give it one more light bulb. And we see this is already shooting up above the 6.3. It's not serious. 304 volts, that's fine. You know, it's supposed to come down to 290, 291. It'll be fine. That'll be fine. That doesn't worry me. This thing might stay a little too high, especially when we get the 240 volts supply on and no restriction. The point is, this thing's working, and it's actually quite interesting, the number of dial lamps they have on here. Let me show you what I mean. I'm going to switch off these lamps so we can get a better view. That gives us a better view of these lights. We've got these two dial lamps over here. We've got, there again, we've got the mono and stereo. So those lamps are working. And you want to know something else? The magic eye is working. But stranger still is that when you connect stereo, oh, it's gone out. It was just residual. So mono and stereo is working over there. For some strange reason, that comes on and then goes off. Don't know what that's about. So we've got long wave, and this has got a light bulb on here, little dial lamp underneath the button, and that's working. That's working. Shortwave, that's working. FM, that's working, and we can see the magic eye trying to glow through there. So we've got 1, 2. Oh, there's a ferrite antenna, which I think has a dial lamp on here. No, it doesn't. I thought there was a dial lamp on there, but there isn't. So we've got 1, 2, 3, 4, 5, 6, 7, 8. And then this is the speech and music. And for speech and music, there's another 2 light bulbs. Speech, music. Oh, and there's something else on here. When you switch the automatic on, there's a light there as well. So you can see that going on and off. I actually thought the antenna had a light as well, but it doesn't. So if you can imagine this in a dark room, it's going to light up the lounge. There's another one down here if you've got automatic on, little green LED. So this thing is pretty, it's like a Christmas tree. But I'm glad that this thing is actually powering up. There's no shorts. It's drawing very little current, 90 milliamps. It's probably just some leakage on some of the capacitors, I'm sure. The ones that find their way to ground. And also, of course, the dial lamps and the magic eye that's got the heater on as well. This thing is steady on 304 volts. So far so good. I don't see anything really serious to worry about. So I'm glad that this first experiment, this first test is proving successful. I've also found out why the FM button gets stuck. It's loose. The button itself is shifting forward, so it obviously needs to be glued in there a little better than it is at the moment. But this thing looks really good. I mean, look at it. I like it. I like it. Okay, step 1, successful. To understand this stereo mono thing, I decided to do one of my little descriptions here where I take the schematic, I do away with everything that hasn't got to do with the section that I want to understand, like that. And what I've got now is the output, the secondary of the output transformer, and all the speaker connections and all that stuff to do with the speaker. There's one other thing we can do away with here, and that is this SP1 switch. That's the speech or music. When you push it down, I believe it makes. So we'll get rid of that. It's got nothing to do with the stereo and mono. But now we've got 3 switches here. One is TST3, that's from the stereo switch. TST2, also from the stereo switch. We've got some plugs. You see that? 1, 2, 3, and 4. This is that little socket, plug and socket system that the speaker system is connected to. And that then gets used to connect this whole system to the radio without having to solder anything. But as long as we remember that these are the sockets that go to the radio from the speakers, we'll be fine. So the first thing we need to do is let's look at what happens when you have mono selected. In other words, you just want the radio to play. Then you've got 3 choices. You can actually play with this switch where you have internal, external speaker, or both. Let's leave it as J. Where is it? J. J is the in, so that's the internal loudspeaker. Let's leave the switch connected as it is here and see what happens to the signal when we've got mono selected. Just by the way, looking at the switching, mono is when this thing is in that direction. So we'll follow the signal. The ground, by the way, I won't look at. The ground is already made because the secondary ground is connected to chassis, and then this speaker grounding is connected to pin, that socket 2, which is grounded. So the ground of the speakers is made. Same applies here with these side speakers for treble. These two speakers are connected to that socket 3, which goes through the mono stereo. I'm not even sure which way around it is, but when it's made and when you've got speech selected, that's also grounded. So we're only interested on the, let's call it the positive line of the speaker, which is that line over there. What happens to that? Well, let's follow the signal when we've got mono selected for internal speaker. That is what the signal chain looks like. It comes out of the transformer, goes through that switch over there, which is made, goes through that socket and plug 1, goes to there. It can go to there, but there's no switch, so it just follows this line here, over the top, over there, goes through that switch which is made for the internal speaker connection, and it's over to the speakers, so your sound gets through. Quite simple, right? If you have the external speaker connected, for example, over here, similar situation occurs. Signal is here, goes to there, goes through the switch, comes to here, and it goes up to that one because that switch is now made. So it goes to there, to there, to there, to there, up there, there's nothing there, so it'll just come across to there, and it'll go to that speaker over there, which is also grounded. So the external speaker will get the signal. But we've also got this path over here. It goes to there, to there, to there, to there, but now this one is made, so then it'll find its way to that way, and of course we've got to back out the speakers again. So that means that our internal speaker is playing, and so is the external speaker getting the signal. I don't really know what happens if you make this external speaker very low impedance, because these speakers are going in parallel, so there we have it. Now we've got the other scenario. I won't even look at the external one, it'll just send the signal to the external. But we look at the other scenario, which is when the stereo switch is connected. Now with the stereo switch connected, this switch is made to that side. So this output transformer goes nowhere, and there's no signal coming out of here anyway because the B plus has been deactivated, as I mentioned earlier. So what we've got is we really have to look at this connection here as an input, not as an output. So we've got the input coming to ground and coming to here. It goes to there. It's really going to do nothing over here, really, is it? No, it doesn't. So it'll go to there, it'll go to there, and it'll go to the switch over here, and then it'll go to the speakers like that. Yeah, that's how it works. So what we've done is and of course the ground, the negative, is connected to the chassis, and that's connected to the chassis. So what we've got is an input for 2 speakers, or 4, depending on what condition that is in. But basically this is working as a speaker, a passive speaker. And it's, I don't know, it's just a waste. But that's how it works. And as I said before, I like doing these cleaned up drawings to understand how things work. And that's why I was doing this, so I hope that's helped you a little bit as well. All right, enough of this fake marketing. All right, folks, a lot has been done, although it doesn't look like it. But if you look closely, all the paper caps in most of the audio section has been done. Actually, in all the audio section has been done. The reason you'll still see a few over here is because I'm taking this literally one stage at a time. I was only focusing on the audio. Okay, so I've got quite a lot of these caps replaced. These are actually pretty good quality foam caps. They're all there, they're all fitted nicely. There are a few little tricks that you need to be careful with these solder tags or solder connections. They don't have a hole in them. They've got it's like a two forked pins. So you've got to clean them out properly, get that in there. But other than that, everything has been checked in the audio section. There's our power tube, and then there's our the tube that acts as a preamp, taking the signals from the input here and also from the selection coming from the radio, depending on what band you choose. So all that has been done. And as I said, I've not touched anything that is not within the audio section. And you can't really tell what is what until you look at the schematic. And if we look at the schematic, it becomes very obvious very quickly that a lot has happened here. Look at this section over here. This is all the checking that's been done, and it includes capacitors, it includes resistors, it includes pots. And the way I do it is I take it from a logical point, which is the power tube, and I start measuring. Go to pin 3, check what resistance you have to ground, replace that. That's the electrolytic cap. So that one was replaced. And you go back from pin 2, you find that resistor. When you find that point, you find the next point. And that's how to do it. And it's actually not that difficult in this radio. There's quite a bit of space in there. So you can do that. And then every time a capacitor is changed, you replace it. By the way, there is one here. Where is it? Nope, it's not here. There was one capacitor I changed that's not in the audio section. I'll explain that in a minute. But everything was pretty simple. And this is a fairly simple amplifier. You've got your power tube over here. You've got, if we go back here, you've got this one here is the coupling from the preamp triode that then goes through there, and then it goes through that network over here and finally gets fed to the grid of the EL84, which then produces the sound across the primary of that transformer. I won't go into as much detail as I have in the past because I noticed this video's got quite a lot of schematics already. So you'll get your fix from that. But all this is tone shaping. Here's our treble. It's a treble bleed. Rather, this is the bass, I beg your pardon. That's our treble. And what else have we got? We've got a feedback system from a winding on the output transformer, which feeds back to here. There are various choices here depending on what tonal qualities you want. If you choose FM, you're bypassing that. If you use, what is this, TM2? I don't even remember what that switch is. It bypasses that. Otherwise, that resistor stays in place. So a different shaping occurs, and so on and so forth. And ultimately, well, we pass through the preamp stage as well, of course. This is the preamp here. It acts as a preamp to drive the power tube. There's another coupling cap, which then goes to the volume control. And again, this volume control has got that pseudo loudness system where certain points on the volume control itself have capacitor resistant networks which shape the tone. Again, I've explained that quite clearly in a lot of my previous videos, some of it in great detail. But the ultimate point is to get to here. And this over here, or rather this switch over here, is the switch that determines whether you are listening to phono or you're listening to radio. If you're listening to radio, whether it be FM, long wave, short wave, or medium wave, the switch is in the up position. If you choose phono, the switch is in the down position. If it's in the down position, it's taking your signal from here. This is really a tape output. It can be an input as well, but it's a tape output. That's the tape in, that's the tape out, because this point over here, this connection here, this pin here, gets the signal from this point, which is any audio going into your amp. So whatever you've chosen, doesn't matter whether it's from the phono, from the tape, from the radio, it's going to appear over here, and there's a 2.2 meg that goes to this point, and this is now to connect to an external tape recorder, tape machine. But this one acts as an input into here, as does the phono. So it says stereo here, but again, this is a misnomer. The 1 and 3 are shorted out. So this is not stereo. Again, same story. But there's also the dual connections at the back that are phono in, which is mono, the same as that one. But I use these because they're simpler to connect to with banana plugs. But ultimately, you get your signal coming in here. It goes into there, and goes through the entire process with a few controls, like the speech button there, that changes the tonal quality, whether you want speech or music. It also affects the lamp that goes on in the front panel, and also the tone controls themselves. You've got your bass and your treble. So everything is in here to shape your tone that you're going to get going through to your speaker systems, which I've described just previously about how it works. We're only interested in the speaker coming out of here, so I connected a wire to point number 1 and the ground, point number 2, and I've got that going out to the workshop speakers. So this has all been done. By the way, there was one other thing that was done, which is I saw a film cap, a paper cap on top of the tone control, on top of the treble control, and I changed it, and then I was looking for the capacitor to try and paint it, and I wasn't expecting it to be here. I thought it would be in the audio section. It wasn't. It's actually here in the IF transformer, in the first IF transformer, and it's switch 5, which either switches that way or that way, a 15 nanofarad capacitor to ground. And if we look for S5, there it is, bandbreites Schalter. Okay, what that means is bandwidth. So this thing has got a switch which allows you to adjust the bandwidth of your signal, and it says GEC MP2. Well, P2 is a tone control. If we look for it, that's P3. It's over here, P2 on the treble. You see P2? So it tells us that there's a switch on P2, and that's exactly where I found this strange capacitor, which I couldn't identify. And if we take a closer look, we can actually see that there is a switch. You see, this is the capacitor over here, and there's a switch on the underside. If I go around like this, I don't know if you can see it, but it's actually making and breaking a switch on the underside there. So which means that if you want to broaden the bandwidth, you literally take your treble to the top and you click it in, and then that capacitor gets switched over to one side or the other. So this is actually quite unique. I've never seen a band spread switch like this before. Okay, but that's well, fine, it's unusual, but this is an unusual radio. There's one other thing that I want to call your attention to, and that is this capacitor down here. Now this capacitor is actually a paper cap, normal. That's your coupling capacitor from the wiper of the volume control. It is identified as capacitor C46. Now if we look at the schematic, C46 looks slightly different. You see there's this dotted line around here, and it's connected to ground. Now, this just tells us that this is a shielded capacitor. This capacitor actually has 3 legs, and you can't see it here, but one of them is connected to there, and the other one's connected to there. That is ground. So what you do is you can make one. You take a normal capacitor, you wrap foil around it, and then you solder a wire to that foil, and that becomes a shield around your capacitor, which then gets shorted to ground or connected to ground. Exactly the same as the capacitor in the radio is doing, and that will reduce any noise pickup at a very sensitive part of the radio. It's probably one of the most sensitive spots because it's taking your signal from the wiper of the volume control to the first gain stage or the preamp stage of the radio. So that was something that I've shown before. I actually did a small video on it. There's no mystery there. It's just if you haven't seen that before, it sometimes surprises you and you don't know what it is, but now you do. Right, so what do we need to do next? Well, very simply, we need to test this. So I'm going to put this on its right side up. I'm going to connect a speaker to it, and I'm going to feed a signal in here and see what we get. The only 2 tubes that I'm going to connect are the preamp tube and the power tube. So the EABC80 and the EL84, and if those tubes are good, we should hear a tone. All right, folks, ready for the test. I've set up a signal coming in here to the phono banana sockets at the back. It's about 100 millivolts, I believe. It's probably low, but we'll check that later. I'm not sure how much gain this thing's got. I've got the dim bulb ready to go. There's one light bulb on only over here, so 40 watts. I've got this on phono pickup, and the volume sort of halfway. I think we're ready to hit it. Let's hit it. By the way, I've got that at 220 volts. This thing hasn't been modified in terms of dropping resist or anything like that, so I don't want to overstress it. And we hit play or on. Okay, light bulb came on bright. The 40 watt light bulb. It's drawing 110 milliamps. We're seeing nothing. I've got the speaker on speaker rather than dummy load, and I can hear it and I can see it. Let me put it on dummy load so we don't have to listen to that. And look at that. And it's starting to clip up there. But That there is looking great, and that's drawing quite a bit of current. Well, it's lighting up the light bulb. So I'll give it another light bulb. That makes it 100 watts restriction. Let me see what happens if I bring this up. There's no shorts, so I'm going to give them all 4 light bulbs. That's 200 watts. And I'm going to increase this till I get 220 volts over there, which is what the radio would expect. There we go. So that's where it would be under design conditions, as it were. Remember, this is not drawing as much current as it should because there's still tubes that aren't in here. So we're sort of simulating the operating conditions as it was designed for, according to schematics and everything else. And what we've got there is about 2 volts. And then it starts sort of losing its clarity at the bottom. But that's what I wanted to see. Let me change the time base. That's a beautiful sine wave. Beautiful. Okay, that's brilliant. Now let's see what happens if this is 1 kilohertz. So it'll sort of be in the speech range. Let's hit speech. You can see that's set for music at the moment. If I push speech, it clicks on speech, and it's obviously increasing the amount of 1 kilohertz it's going through, because when I do that, it comes down. I don't know exactly how they define, this switch is a little bit dirty, but we'll get that. I'm not sure how they define the actual, see that? The actual tone shaping, but I'm sure they have to take into account the type of speakers and the size of the cabinet and everything else they've got on here. So I'm not going to judge them. Let's try the treble. Yep, that affects the treble. It won't affect the bass. Let me go down to, say, 200 hertz. Oh, I pushed 200 kilohertz. That won't work. 200 hertz, okay. And if I play with the bass, oh yeah, it goes up and down. So the bass has actually quite a big effect as well. Up to where does the bass go? Let me go up here, 400. It's still sort of affecting it. Not much, well it is actually. 5, 6, 7. It boosts the bass from below, actually that's from about below 700 hertz. So there's quite an effect here. But what I wanted to determine is that the amplifier is working, and it's working pretty well. So folks, I'm pretty satisfied with this first stage. It's actually a first and second power supply and power amp. I think that's working well. We'll know exactly when we do the final test at the end inside the cabinet. That's really the best way to test these amplifiers. These speakers are incredibly efficient, so I'm not going to judge its power rating or power capabilities based on what I see on that screen there. But for now, I'm really pleased. A big chunk of this has been done. The big question is there any radio reception? Is the motor going to work? There's all sorts of stuff that we still need to look at, but I'm going to stop for now because I need to do a lot more work there before I tell you about it. So here we have it. And of course, if I push that, I end up with a unpowered speaker with lots of lights on. Strange, but true. Right, I'm going to leave you for now, and I want to thank you for your company, and I hope you've enjoyed that. And if you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can certainly do so on Patreon and PayPal. Links in the description below. So once again, thanks for watching. Bye for now, and stay safe.